This is the video for Lab 4, Physical and Chemical Changes. And this experiment actually gets us into some chemistry. We're mixing things and reactions are occurring. I think probably in experiments 1, 2, and 3, you've learned your way now how to find the experiments and do them successfully. I just want to focus your attention again on a good strategy for the class, and that is to shoot for 20s, 19 or 20 points on each laboratory experiment. Because they're open book and because you can take all the time that you need and you can call me or email me with questions, we just want you to do very well. And that's a good strategy for the class, because if you score high on the lab experiments and the quizzes, that'll buffer you in case you have a low exam score. It's an excellent strategy for the class. So let's begin. Let's look at the pre-lab review page and see if we can come up with some tips for you. Question number 1, are there any specific safety alerts? And what you should do now with each experiment is look for the triangle icons, and that'll guide you where those alerts are given. Question number 2, any specific disposal directions? Well, in this case, look for the garbage can icons. Number 3, what 3 important behaviors will you look for and record in this experiment? When a chemical reaction takes place, there are 3 ways that we have, that common ways of telling whether or not a chemical reaction has actually occurred. And you'll find those 3 ways in the introduction to the lab. What's the difference between a physical change and a chemical change? Well, you could use your text to answer that question, or you could look in the lab introduction. Again, either way. Number 5, are solid samples weighed accurately or approximately in the experiment, and how can you tell? Are the masses recorded in the data pages? If they're recorded in the data pages, then most likely we would like an accurate weighing. If they're not recorded, then you're just weighing approximately. So see if they're weighed accurately or approximately. 6, 7, and 8, and 9, I don't think you'll have any problem with those, and they're pretty descriptive. Let's look at the data and report pages. Part A deals with solution formation. And what we'd like you to do when you complete this experiment is to tell whether or not solution formation is a physical or chemical change. And remember how you'll decide if a chemical change occurs, if a reaction occurs, if there's a change in composition. If there's no change in composition, then it's physical. So with each of these parts of the experiment, we'll be trying to decide if a change in composition has occurred. In solution formation, you have an original material, and then you have a recovered material. And you'll compare the properties of those two. If it looks to you, when you compare their properties, that they're the same, then you'd conclude there's no change in composition and it was a physical change. If it looks to you like the properties of the original and the recovered are different, then a chemical change will have occurred. And you'll decide whether it's physical or chemical by looking at physical and chemical tests on the original and the recovered. Flame color, I know, is a physical test. Result of adding silver nitrate is a chemical test, but that's irrelevant. What we're interested in doing is gathering data on the original and recovered and concluding whether or not solution formation is physical or chemical. So flame color, well, the original solid will produce, we'll say, color A. And the recovered solid, when you test it, will produce color B. If A and B are exactly the same color, then over here in the result page, you'd say, no, it doesn't, this particular test doesn't indicate a change in composition because they're the same. If the color of A is blue, we'll say, and the color of B is red, they're different now, and we'd say, yes, that indicates two different substances and a change in composition. And you'll use the result of adding silver nitrate in the same way. You'll make an observation for A, we'll say, and over here you'll see what happens when you add silver nitrate to the recovered solid and make observation B. If these two observations are the same, you'd say no. There's no indication of a change in composition. It looks to you like the original and recovered are exactly the same. But if there's a difference, you'd say yes. Let's look at part B. Here we're heating copper carbonate, and we're testing the untreated sample and the heated sample in two different ways. Again, we're looking at sample color, and we're looking at what happens when we add hydrochloric acid to the samples. Again, you'll be comparing color A and color B. I'm going to scroll down just a little more. If they're the same color, you'd say no. It doesn't indicate a change in composition. If they're different colors, you'd say yes. Looks like I've got two different substances and there's been a change in composition. And do that with HCl as well. You'll make two observations on the before and the after, and if they're the same, you'd say no. If they're different, you'd say yes. Looks like I have two different substances and there's been a change in composition. Melting iron chloride. Well, here we've jumped up from 2 to 4 different tests. We're looking at the color of the untreated sample and the melted sample. What happens when we add silver nitrate? We'll make observations. What happens when we add ammonium thiocyanate? And again, we'll look at the color. And potassium ferrocyanide, we'll look at the observations there. And we'll compare over here in the report part. Again, if it looks like the two tests are exactly the same, we'd say no. If the two tests differ, we'd say yes. And it could be that in some of these tests you'd get no, and in some cases you might get yes. They don't all have to be yes or no consistently. Part D is sodium bicarbonate plus hydrochloric acid. Two tests of the unreacted and the recovered. And again, the same process. Part E, combustion of magnesium. And we're looking at the sample of magnesium before combustion and the material that's left when we're all finished. And now we take all these report pages or report data and draw some conclusions. In solution formation, if both of the tests came up the same, and in both cases you concluded that there wasn't any indication for chemical change, in other words, two no's, then you'd say physical. If you came up with two yeses, you'd say chemical. If you came up with one no and one yes, you'd still say chemical, because one of the tests is indicating that you've got something different. Do that for parts A, B, C, and D, and E. And again, if there's any yes, it's chemical. To be physical, it has to be all no's. And I've summarized that right there, I think. Change in composition, all no, it's physical. Any yes, it's chemical. Let's look at the questions at the end of the chapter. Sometimes these are tough. Certain popular antacids are dissolved in water with much fizzing. That with much fizzing is sort of a key, a key phrase, because when a gas is given off, sometimes we describe it as bubbling, or gas is given off, or fizzing. There are different words that we can use, but it indicates that something new has been created, and that gas is bubbling to the surface. So keep that in mind as you try to select the proper answer for number 1, physical, chemical, or can't tell. Number 2 has a key word in it also. It's got that word bubbles. So again, let that give you a clue to what's going on. And number 3, it says fish need oxygen to survive. Oxygen gas is dissolved in water used by fish, which remove it from the water by means of their gills. Classify the change that occurs when oxygen dissolves in water. Well, the key question is there a change in composition? We had oxygen in water when we started, and when the oxygen enters the fish, it's still oxygen, isn't it? Number 4, hey, there's that word fizzing again, and that'll help guide you to the correct answer. Number 5, seawater can be made into drinking water by boiling the seawater, collecting the steam, and condensing steam to liquid water. Classify the changes in water that occurs when it is boiled to steam and then condensed to liquid water. Well, we had water when we started, and we still have water when we're finished. There hasn't been any change in composition. So let that guide you a little bit. Hey, I hope you have fun with this experiment and enjoy it. And remember, shoot for a 20.